All right, everybody. Here is the Chapter 8 lecture. Now remember, there is no quiz for Chapter 8, and in addition to that, there's no quiz for Chapter 10. So, Chapters 8 and Chapter 10, no quiz. There will be a writing assignment, and there will be a discussion assignment for both chapters, but no quiz. Okay. So, Chapter 8 actually discusses intelligence and cognition. I think the textbook author made a mistake on this one. I think an entire chapter should be afforded intelligence, and it used to have an entire chapter on just intelligence, but I think they really messed that one up. Intelligence and intelligence testing is a hallmark of psychology. It's what made psychology the testing profession. And because of that, it was the intelligence test in the early 1900s that distinguished psychologists as those who gave tests. So, I think it's a shame that they turned two chapters into one in this regard. But yeah, they don't agree with me. But we're only going to talk about the intelligence and intelligence testing part of this. Okay? Best definition of intelligence was given by Jean Piaget, who we'll talk about in the next chapter on development. His definition of intelligence is adaptability. The most adaptable individual is the most intelligent individual. So let's start a little bit by talking about intelligence testing. Mental ability tests versus personality tests. Well, we talked about personality tests already in Chapter 11. That was the second chapter we covered, our second module. If you'll remember, personality tests measured attitudes, interests, and values. Mental ability tests measure specific aspects of cognitive functioning. Now, there are three basic mental ability tests, three types: intelligence tests, achievement tests, and aptitude tests. Intelligence tests, well, by the end of this lecture and after reading the chapter, you'll have to decide whether or not you think that these tests actually measure intelligence. Achievement tests are tests that measure an individual's academic functioning level. So when you all took the stupid WASL or any of its permutations, that was supposed to be an achievement test. It was a crappy achievement test. The WASL never got over a 0.6 reliability correlation. What that means is that the WASL was only 36% accurate. That's a really, really bad test. These intelligence tests that we're going to talk about in this chapter are in the low to mid 0.9s in reliability correlation. That means they're almost perfect. So they're very, very good tests. We'll talk about what that means. But the achievement test tells you what grade or age level a person is at in reading, writing, and arithmetic. That way, if we have a need to determine if someone has some type of a struggle with learning, we can give them an intelligence test and know where they should be functioning academically. And then if we give them the academic test and we find that they are remarkably low or remarkably lower than their IQ test would predict on some of the academic functioning, then we can take a closer look at it and determine what it is that's causing them to not be learning. And these could be learning disabilities. This could be attention deficit disorder. Recognize a learning disability isn't a horrible thing. I mean, it's difficult to work through, don't get me wrong, because it does make life a whole lot more difficult. But actually, individuals who are diagnosed with learning disabilities have an average higher IQ than the average individual, because to have a diagnosis of a learning disability, you have to have 3 criteria. One is average to above average intelligence. Well, if we're only measuring people or including people who have averaged and above average intelligence, then we're factoring out all the people below average. So if you factor all the people out below average, that means those people with learning disabilities have an average IQ of about 110 as opposed to 100. So make all the jokes you want about individuals with learning disabilities, they probably have a higher IQ than you do. And then an aptitude test, it measures specific abilities. Now, it can be as simple as a button-pushing test. You know, if someone goes into work at a factory and they have to push a button when they hear a certain pitch beeping sound, well, that's an aptitude test for button pushing. Well, there are much greater aptitude tests than that, much more complex. I mentioned previously that the ASVAB, the Armed Services Vocational Abilities Battery, is the biggest aptitude test that there is out there. And it has a quick and dirty IQ test in it, as well as achievement measurements, but also measures many, many aspects of aptitude, which is necessary to determine what someone is going to be really good at in the armed services. Okay, so that's intelligence, achievement, aptitude. Now, what makes a test a good test? 4 things: standardization, norms, reliability, validity. What is standardization? It means that a test is given the exact same way every time to every person. You can't give it differently. So I've got here a sample of the Wechsler Adult Intelligence Scale. It's an old version. Because it's an old version, I can show it to you a little bit. This test has 12 subtests that make up the entire test. 13 subtests that make up the entire test. Let's say someone has really bad ADHD, and you know they do, and they're taking this test. Well, there is a measure that is a very good indicator of ADHD. It's called digit span. It's very simple. You simply read series of numbers, and the series get bigger and bigger and bigger and bigger until the person can't give you the series correctly any longer. And then you do the same thing backwards. Well, individuals who are already a bit fatigued are going to do worse. And so someone with ADHD who's already going to do poorly on this, because it's a great measure of attention and concentration and short-term memory, they're going to do more poorly than if that test was up front in the series of tests. So if you wanted to be nice and give that subtest up front, well, the moment you do that, you have unstandardized the test. No longer does the test give you any valid results, because you didn't give it the exact same way that it's given to everybody every time. So standardization is incredibly important. Okay? Next is norms. What do we mean by norms? Well, I forgot my little whiteboard. Hang on a second. Norms simply means normative data. Well, what the heck is normative data? That means that you give the test to a random sample of a whole bunch of people. And then upon giving that test to a random sample of a whole bunch of people, you then create a nifty little bell-shaped curve. The bell-shaped curve presents the norms of the test. So let me give you a simple example of what that would look like. Well, let's say we gave this test to about 30,000 people across the country. And they were randomly selected, adults. Then we could disperse them so that they all fit on our wonderful little bell-shaped curve, right? Well, what would that look like? Well, the average IQ on a test like this, the average is 100, and a standard deviation is about 15 points. Okay? Now, there are a couple of things that we know about standard deviations. When they're standard, that means they're the same. So it's the same distance from here as it is to here, and here as it is to here along this line. And the same distance here to here, and here to here. So we've got two standard deviations set up here. Well, we know that if we have a large enough sample, normative sample to work with, we will always have 34% of the population between the mean and one standard deviation below, and we will have the same between the mean and one standard deviation above. So right here, from here to here, we have 68% of the population, 34 and 34. Well, a score of one standard deviation above the mean is the average of 100, and the standard deviation equals 15. That means it's 115. Down here is 85. Okay? So between a score of 85 and 115, you have 68% of the population. We always know that if it's a normal bell-shaped curve, between +1 and +2 standard deviations, we have about 14% of the population. 13.7 technically, but that's what it is. So now we know that between a score of 130 and 70, we have 96% of the population, meaning that above 2 standard deviations is 2% of the population, and below 2 standard deviations is about 2% of the population. Now we know this with all bell-shaped curves, and we've set it up like this statistically so that we know it. This way, when we give a test to somebody, and it's an 18-year-old, and that 18-year-old gets a score of 117, we know that that 18-year-old scores better than this much of the population. Actually, a score of 117 would be right here. Now we're at the 82nd percentile. Right here would be about the 85th, 86th percentile. So that means that person scores better than about 86% of the population on an IQ test. That's pretty bright. Okay? If they score 130, they would score better than 98% of the population. In other words, we create norms and put them on a bell-shaped curve like this so that we can give the test to somebody and then compare how they score to the rest of the population, because we've got a big sample of people that we've included in our normative data. So that's norms, extremely important. Okay, now The next concept that I want you to be familiar with is reliability. Reliability means how much can you trust the score of the test. Like I said to you, these IQ tests are about 0.94. 1.0 is perfect. That's a really, really good test when it comes to reliability. That means if somebody gets a specific score on one of these tests, you can really, really trust that that is likely to be the best prediction, the accurate score of that individual, the real score. There are a number of ways to test reliability. There are actually 4 methods. One method is the test-retest method. You give the test once, then at a later time you give the test again to the same group of people. If the test is a good test, shouldn't it give about the same score both times? It should. So, actually, people do a slight bit better the second time because now they're familiar with the test after they've taken it the first time, so the second time they do a little better. But we know that, and so we calculate that in statistically and even it out. But the downside of that is you have to give the stupid test twice. That's a pain in the neck. Well, the next test, you only have to give the test once. The next method, of measuring reliability is called split half reliability. Well, what split half reliability means is that you literally split the test in half. Now, all of these subtests on these IQ tests, they all start with the easiest item and they end with the most difficult one. Well, that way, let's say in the information scale, there's 30 questions in that information scale. Well, item number 1 and item number 2 are just about the same difficulty. And 3 and 4 are just about the same difficulty. And 5 and 6 are just about the same difficulty. So literally you split that thing in half. You give the test to a whole bunch of people, but then statistically you take all the odd items and you put them over here and all the even items and you put them over here. Now, if it's a reliable test, a trustworthy test, shouldn't the odd items and the even items give you about the same score as each other? Well, you do that with all of the different subtests also. That's called split half reliability. It's easier, but the downside to split half reliability is you've split the test in half. And if you split the test in half, then you've lost half the power of the test. Well, not half technically, but you've lost some of it. Okay? The next method of measuring reliability is called parallel forms. This means you got 2 different tests. And you make sure that item number 1 on test 1 is equal in difficulty to item number 1 on test 2. And item number 73 on test 1 is equal in difficulty to item number 73 on test 2, per se. This is actually how the armed services... Sheesh, lots of noise out there tonight. This is how the armed services measures their intelligence, at least gross intelligence. There's a short paper pencil intelligence test in the ASVAB. It will either be the alpha form or the beta form. The alpha form and the beta form are of equal difficulty to each other on all their items. How do we know this? Because millions and millions and millions and millions of people have taken the test. And they have this gigantic fund of data that shows that if people get item number 1 right on the alpha test, they're going to get item number 1 right on the beta test, etc., etc. It's not perfect, but it's a really good method of reliability. The only downside with this is it's hard enough to make one good intelligence test. In this case, you have to make two of them. And then finally we have inter-rater reliability. Inter-rater reliability means you have a group of people who are all scoring the same test. They're all given copies of the same test, and they all score it because they've been trained how to score it. And if it's a good test, what should happen? Well, they should all be able to score it right about the same. Now, that's what happens with these IQ tests, like I have here that I'm going to show you. Two clinicians can give the exact same test, and you will get incredibly close measurements between the two administrations. They'll be very, very close. So that's inter-rater reliability. Now, we also have validity. Validity is a different animal than reliability. Reliability means you can trust the score. But just because you can trust the score that the person or people will get the same score in multiple administrations of the test doesn't mean necessarily that the test is measuring what it's supposed to measure. So let's say we put together a test for depression. We only wanted it to be 12 items long because all the other tests were much longer. And when people are severely depressed, they don't want to spend a whole lot of time taking a test. So what we would do then is we would compare that test, the results we get on our short test, to the results of another test that we already know is a good test, for example. Well, let's say, now we know that sleep and sleep disturbance is a significant symptom of depression. Well, what if we put too many questions about sleep on our little test? Is it possible that that little test then could end up measuring sleep disorders rather than depression, and it wouldn't be a good measure of depression? People might get the same score over and over and over again, but that doesn't mean it's measuring what it's supposed to measure. So, because of that, we need to measure validity. So, there are three types of validity. The first two I can explain to you pretty easily. The third is very complex, so just kind of trust me on it when I explain it to you. The first is content validity. And another term that we use for this is face validity. In other words, does on the face of it look like it'll be a good test? Well, who do we have determined that? Well, we have experts in the field. So if we put together a test for depression, we would then go find the 500 most frequent publishing clinicians in studies who have done studies on depression. And then we would send a copy of the test to all 500 of them and ask them to rate the test, each item as well as the whole test all together. And then we'd plug it all into the computer and see if it had a high level of validity or not, according to the experts. Most of us would trust a large number of experts like that. The second type is called criterion-related validity. I also like to call this statistical validity. Criterion-related validity means, well, I actually explained it a little earlier. How well does our new test compare to an old test that we know measures depression really well? So we'd give our subjects who were depressed both our short test and the longer test, and see if our short test did as well as the longer test. Meaning, we're comparing the results of our test to an already existing criterion. That criterion is the old test. This is done in the armed services. Lots of people who sign up for the armed services want to become mechanics in the armed services. Believe it or not, that's a very popular job that people like to get. Well, how do you know that somebody is going to be a good mechanic? Just because they say they like it? Well, just because they say they like it doesn't mean they're good at it. So, here's what they do. First of all, if everybody who said they wanted to be a mechanic, you took them into the shop and you had them take apart a motor and put a motor back together to show their mechanical abilities, how much time would that take in the armed services? A lot of time and a lot of money. So they have to figure out a better way to estimate whether or not people are going to do well as a mechanic. So what they do instead is they create a test. And they make that test be the most predictive test they can possibly put together that would predict how well somebody does in mechanical abilities. And then they take a whole bunch of people, select them randomly from the armed services. And if you're in the armed services, if you're told to go do something, you go do it. So they would go and take the paper pencil test, and then they would go into the shop and take apart a motor and put it back together. And then the ratings that they got on the two, their scores, would be compared to each other as a group. And if the written test did as good a job as the physical mechanical exercise, then that would be using criterion-related validity. What's the actual criterion? Taking apart the motor and putting it back together. That's true mechanical ability. The test is supposed to measure how well somebody could do that, and that's how they do it. They compare it, and if they find the test isn't so great, then they make the test better, and they just keep working on the test until it becomes very good at predicting how well they would do on the mechanical abilities test. So, criterion-related validity. The third type of validity is called construct validity. What is a construct? A construct is an overall belief. Okay? What do we mean by that? Well, if we were to have two psychologists create a test for depression, and one were a psychoanalyst and the other were a behaviorist, would they create different looking tests? Well, yes, they would. They come from different places. But could they both be equally as accurate in assessing depression? Well, yes, they could be. So construct validity means how you measure construct validity is you determine how closely the test is true to its underlying philosophy. In this case, how good was the psychoanalytics test true to psychoanalysis, and how good was the behaviorist's test true to behaviorism. And the idea is, if they're true to their theories, and those theories are good theories, then the tests are going to be good tests. So just kind of take that one for on faith just a little bit with me, because we could spend 2 full weeks discussing construct validity and not be even close to figuring out what it all meant. It's a really difficult concept to understand. Okay. Now let's talk about the 2 major tests there are that we use. This is the Stanford-Binet and the Wechsler scales. Stanford-Binet and Wechsler scales. Okay? The Stanford-Binet is the first one. Stanford-Binet was originally created by Alfred Binet in 1906, 7, 8, something like that. Binet was commissioned by the French government to come up with a test that they could give to children that would help them determine whether or not kids were best suited to go into education, best suited to go into the trades, or best suited to go work in the fields. So what's that really mean? Well, were these kids smart, handy, or dumb? Well, the test was never used for that purpose because parents didn't like it. But remember, the French government is a social democracy, and so they lean a little bit more towards socialism than we do. Not that that government is bad and ours is better or not. It all depends on who's running the government. So, but bottom line is, they wanted to find a test that would determine how people would perform on these tests to help determine how they could best serve society. Because in a social democracy, the social good, the society's good, is of greater importance than in our Republican democracy, in which we focus much more on individual rights. That being the case, he put together the Binet intelligence test, and it was a good intelligence test until Terman at Stanford University got a hold of it and made it a little bit better. Actually bought the rights for it, brought it to Stanford University in the early 1930s, I believe, and ultimately turned it into a really good test that still is a good test. It's been revised a number of times since then and renormed, but it's a really good test. And his test had a formula, an IQ formula. So, what's the IQ formula? It's pretty simple. IQ equals mental ability divided by, or mental age, excuse me, divided by chronological age times 100. Okay? So mental ability mental age divided by chronological age times 100. Well, the only thing we don't really know here before a person takes the test is the mental age. We know their chronological age. We know the number 100. So the test gives us the mental age. So let's say a kid who is 10 years old scores the same score as the average 12-year-old. And you multiply that times 100, and what do you get? 120. And where's 120? Well, that'd be about right here on the bell. Oops, you can't see that, can you? That'd be about right here on the bell-shaped curve. That would be a percentile score of about the 88th, 89th percentile, 90th percentile, right in there. So that's a really bright kid, right? Because he's 2 years ahead of the average 10-year-old. What does that mean for somebody who gets a score of a 7-year-old and they're 10 years old? That means their score would be 70. So they'd be down here, way down here on this end. Okay? So that's how the Stanford Binet is configured. On the other hand, we have the Wechsler scales. The Wechsler scales determine IQ differently than the Stanford Binet. The Wechsler scales, and there's 3 of them, and we'll talk about that a little bit. There's 3 of them, but they use what is called deviation IQ, meaning how deviating or how different is an individual's score from the average on the bell-shaped curve. So it's just a different way of figuring out the same thing. The Stanford Binet, its standard deviation is actually 116 points. So it's slightly different, but they are about the same in scores. They do have strengths and weaknesses, each of them. When we give IQ intelligence tests, we use concepts of verbal functioning and performance functioning. Verbal functioning is reading, writing, and arithmetic. Okay? Anything that would predict how well someone would do in school. So the information scale on the Wechsler scales is a verbal scale. The vocabulary subtest is a verbal scale. The arithmetic subtest is a verbal scale. And then there are other subtests that measure abstract thinking and social intelligence and lots of other aspects of how well it would predict that someone might do in a school setting. The performance items, on the other hand, are all of the eye-hand coordination, visual spatial reasoning abilities. So on the Wechsler scales, you end up working with these blocks. You have 9 of these blocks. They all have 2 red sides and 2 white sides, and then they have 2 sides that are half red and half white. And we take them and scatter them on the table in front of us, and then we have a picture shown to the individual. And they have to put the blocks together so that they look like the picture on top. Okay? And the individual has so much time, and how much time they do it in is calculated into the whole thing, and all that kind of stuff. Can't see the top of my head, can you? This would be a performance item. Another performance scale in the Wechsler scales is, in essence, puzzles. This one's called block design. It doesn't really matter what the other one's called. But in this one, you are taking all of these different pieces of a puzzle, and they're all set out the exact same way every time. That's standardization, right? And you have to determine what this thing is quickly and put it together. Well, what is it? Well, what it actually is an elephant. And here's how you put it together. Okay, put it together like that. And then you take this and put it in here like that. And you put this on top of it. And then people always get confused about what this is. Well, what the heck do you think it is? It's a trunk, not a tail. Okay? And so you put the puzzle together, and it takes you so much time to put it together. And you get a score based on how quickly and how accurately you put these things together. These would be performance items, visual spatial reasoning, perceptual speed, things like that. How quickly you can figure things out and do them. Okay? So, those are performance items. The Stanford Binet does a pretty good job of verbal items. In fact, does a little bit better job on the verbal items than do the Wechsler scales. The Wechsler scales, on the other hand, are more balanced in between the verbal and performance items. They do better on performance items than the Stanford Binet, and they're pretty balanced between their verbal and performance items, whereas the Stanford Binet is more heavily weighted towards the verbal items. In addition to that, because of the way the Binet is put together, it does better in measuring younger people. It actually begins at 2.5 years old and goes to, dead. And because it's good at measuring younger ages, it's also good at measuring better developmental disabilities. Mental retardation is measured better by the Stanford Binet because it's more sensitive at the younger ages, and individuals with mental retardation are scoring more like much younger people than they are. And so the younger it can go, the more accurate it can be in its measurement. Okay. The Wechsler scales, there's 3 of them. The first one is called the WPSI, the WPPSI. I actually have a copy of it here. It's not so great a test. As I said, the Wechsler scales don't do well at the younger ages, and this one goes from 4 to 6 years old. The only reason it was ever created was so that they could try to make it compete with the with the Stanford Binet, but it just doesn't do as well at those younger ages. It's easier to give though, and it's a little shorter, and so people tend to give the Wechsler scales more frequently than they do the Stanford Binet. The second test in the series of 3 for the Wechsler scales, and by the way, this was David Wechsler at New York University, NYU, who put these together also in the, I believe it was late 30s, early 40s. David Wechsler also created the WISC. Oh, by the way, the WPSI, the WPPSI, is Wechsler Preschool Performance Scale of Intelligence. The WISC, W-I-S-C, is the Wechsler Intelligence Scale for Children. And this goes from 6 to 17, and it's a very good test. It does just as well as the Stanford Binet, and in some ways better. As the Stanford Binet does a little better than the Wechsler scales in some ways too. But again, it's easier to give, shorter to give. It's the most commonly one given. And this is the test that is most commonly given because this is what's given in the schools when there's need to measure whether or not an individual has difficulty with some type of learning issue. And then the adult scale is the WAIS, W-A-I-S. That's what this one is called, the WAIS-R, W-A-I-S-R, Wechsler Adult Intelligence Scale. Now this is the R. After the R was the WAIS-3, and then there was the WAIS-4, and then there was the WAIS-4R, and then there's the WAIS-5. So, you know, we've got lots and lots of reconfigurations of the test. It looks about the same. A little bit's added, a little bit's taken away each time, but mostly it's that it has to be renormed. And being renormed simply means that it has to be it has to fit the current population. If you think about it, how much more do kids know nowadays than they did 50 years ago? You take a 10-year-old and you ask them their fund of knowledge now compared to 50 years ago, and kids have tons more knowledge and information. Why? Because they have so much more information available to them. So we can't use the same norms on these IQ tests that we used 50 years ago. They have to be consistent with the abilities of the kids of the age now, and adults for that matter. Okay. They all have some weaknesses with measuring elderly people. People who get older, they slow way down. Have some difficulties with that. And so we have to statistically make sure that we're testing people and comparing them with other people who are of the same age and same basic functional abilities. So my hands used to be lots faster when I was younger. They're not so fast anymore when I play cards with the family. They only include me because they know that they can beat me. But I used to be lots faster. Well, that's because your skills slow down with age. It's just a reality. Okay, what are the extremes of intelligence? Well, if we pull out our bell-shaped curve, the extremes of intelligence are the highest 2%, above 2 standard deviations, and below 1 standard deviation. That's 2% of the population also. Do we worry about these people up here that are 130 IQ and higher? Heck no, they do well no matter what situation they're put in. The great majority of them. Are there some that struggle here and there? Yes, but very much the exception. For the great majority of these people, the higher the IQ, the better the basic functioning level. Down here, on the other hand, is where mental retardation starts. There are 5 stages of mental retardation. The first stage is between 1 and 2 standard deviations below the mean. This is called borderline mental retardation. These are people between an IQ score of 85 and 70. These people are referred to as slow. They can do a lot of things, and if you give them enough time, they'll be able to do it. But there's some things they just won't be able to do. Folks who score down here, they're not going to take calculus and do well. Okay? The next level is from a score of 70 down to a score of about 50. Your book actually is a little wrong in the way they divide it. 70 to 50 is called mild mental retardation. And the score of 70 is the score where legally people are determined to be mentally retarded. And we still use the term mental retardation. It's not a bad term. It's an accurate term. It's slowed mental functioning. So people between 50 and 70, these individuals will actually receive federal funding because of their scores. They can do a lot. They can learn to read, especially toward the higher portion of that group. They can learn to do a lot of things, but no matter how hard they try, they're not going to college. It's just not going to happen. Their intellectual functioning is compromised. They are usually in group homes, or if they live at home, they need some supervision. They can't manage their own finances. There are a lot of things they can't do that they need help with, but they can do a lot of things. A lot of folks in this range will work at fast food places and do a wonderful job at the jobs they do. From 50 down to 35 is moderate mental retardation. Oh, by the way, mild mental retardation are referred to as teachable. Kind of a nasty term, isn't it? Moderate, from 50 down to 35, these individuals are referred to as trainable, believe it or not. Woof woof, right? Pretty nasty name. These individuals can do some minimal tasks. They can work in a sheltered workshop or something like that. They're going to need a lot of supervision, not constant supervision, but a lot of supervision. Many of these individuals will live in some type of facility. From 35 down to 20 is severe mental retardation. These folks almost need complete supervision. If they are even ambulatory or have language, that's a big deal for them. There's just a lot of non-functioning capacity that they don't possess, or a lot of functioning capacity they don't possess. They need lots and lots of help and assistance. These folks, if they ever are able to take care of their own personal hygiene, it's a big coup. And then we have folks from 20 to 0. This is called profound mental retardation. Those who are diagnosed with profound mental retardation need 24/7 supervision all times. There is no, they really can't function. When I was 16 years old, my high school psychology class went to the Delaware State Training School. And there we were taken to a room where children who were hydrocephalic were being kept. And when I say kept, that's all that was happening. There were 2 children in that room who had heads the size of your outside trash cans. These children's heads were filled with fluid. Now, you remember down in the inside of the brain, actually, excuse me for a moment, I'll go grab a brain so you can look at it. So here's a brain. This is an actual brain. It's a 3D image. It's a 3D print of a real brain. This is a real individual's brain. Okay? So this is the size of a real brain. Okay? You take it apart, break it in half like this. You have the midbrain in here, the cerebellum's over here, the brain stem's down here. Okay? And if you look in the middle of the two sides, you see two holes right there. Those two holes that go together, those two holes are called ventricles. Inside of these two holes is where cerebrospinal fluid is produced. So all of the fluid down that's bathing your spinal cord and the fluid that is around and in between all of the crevasses in your brain, that's where this is all created, in here. And there's also another ventricle that's right back here. If you see this little hole right here, that's a third ventricle, and there's a conduit that connects them. And then there's one more ventricle that is down in the brain stem, right about down in here. Tiny little hole way down in deep. And these are all connected. And then they go down into the what do you call it? Down into the spinal cord. Well, these ventricles, if they are blocked, cause a hydrocephaly. And what does hydrocephaly mean? Well, it means water on the brain. It's really more than water on the brain, it's water in the brain. And it expands the brain from the inside out and stretches it. Now, nowadays, those children would have been permitted to pass. They weren't back then because I grew up in the dark ages. But it's the spreading of the brain out that way. Well, those individuals were profoundly mentally retarded. All they could do was breathe and digest food. That was the extent of their abilities. So, there you go. All right. How much of intelligence is inherited? About 60%. 60% is determined genetically. That's our best guess. Of course, the research that's being done now likes to suggest, and is probably accurate, that it's more like going to be more like 70% is inherited. I think that's how things are going now, and will pan out in the next 10 years or so. But right now we say it's about a 60-40 split. 60% genetics and 40% environmental influence. 40% is still a lot. It used to be 50-50. That's what we used to say. Now we say 60-40. I think it'll end up 70-30. But research tells us that smart parents tend to have smart kids, and not so smart parents tend to have not so smart kids. That's just the reality, even if those kids are not raised with those same parents. All right. Last thing we're going to do is talk about 3 theories of intelligence. First theory is the Spearman two-factor theory. Spearman's the guy who came up with the formula for the correlation. You can thank him for all that work that you had to do learning what a correlation was. Spearman's two-factor theory was very simple. First, you had the G factor. G factor meant general intelligence. The other factor is the S factors, meaning specific abilities. And if that sounds a little bit like how I described the IQ tests, that's exactly how I described the IQ tests. Okay? They are constructed after Spearman's model. So Spearman said general intelligence and then specific abilities that all add up to the general intelligence. Along came Thurstone after Spearman, who came up with the theory of the 7 primary mental abilities. His 7 primary mental abilities, he said, could not be all added together into one conglomerate. He said they had to be considered separately. And what were his 7 abilities? Well, you can look in the book, but you have word fluency, verbal word comprehension, arithmetic abilities, he called it numerical abilities, perceptual speed, how fast you are at doing things, memory, visual spatial reasoning, etc. Okay, so these 7 primary mental abilities, they're interesting. He said they couldn't be combined, although we certainly use them. So, for example, when I do psychoeducational evaluations, I will give an IQ test, and sometimes I will find that individuals have an interesting dynamic when you combine 2 of their mental abilities, like memory and words versus memory and numbers. Some people are good with memory and numbers, but memory and words, they're horrible, or vice versa. And so we find that there are interactions between some of these mental abilities. Now, another theorist came along and created a great big model where he created 150 different combinations of different mental abilities and tried to use that. Well, it was a nifty idea, but it was completely unusable. And then later on, Cattell and Horn came along, and we talk about crystallized and fluid intelligence. They tried to simplify things a little bit, I guess. Their concept of crystallized and fluid intelligence means, well, crystallized intelligence is the gathering of information for the purpose of problem solving. And so, I'm 62 years old. I'm lots older than most of you. I probably have a much larger crystallized intelligence fund of knowledge than you do. That's just because I've had 62 years to gather it, compared to your 18, 20, 25, 30, however many years. And this is why we go to experts in certain areas, because they've had long periods of time to gather lots of information. That's crystallized intelligence, the gathering of knowledge for the solving of problems. Fluid intelligence, and by the way, crystallized intelligence has a really steep learning curve in the first 15 years of life, and then about 18 it starts to level out, and then it continues to increase just slightly all over time until a person passes away. Because really, people don't become senile generally until quite a bit later in life. People between the ages of 60 and 70 generally are not afflicted with Alzheimer's. 70 to 80, it's less than 5% between 60 and 70. 70 to 80, it's about 15%. 80 to 90, it increases to about 25%. And then 90 to 100, even more. So the older somebody gets, the more likely they are to have some cognitive degeneration. But for most of those people, that crystallized intelligence continues to grow with time. And then the fluid intelligence. Fluid intelligence is are those abilities that people are very good at when they're young, and then they slowly decrease with time. So this would be eye-hand coordination. This would be perceptual speed, like in Thurstone's theory. How quickly you can do things, that type of ability. And it increases rapidly again up towards the age of 18. Once you get to 18, on average, as an average, it slowly begins to decrease with time. And that's why I can't play cards. nearly as well as I used to be able to play cards on these family card games that we do. Okay, there's your lecture. It's a little longer than usual. Remember, no quiz, just writing assignment and discussion. So, we'll see you soon with Chapter 10 and its single lecture also. Talk to you later. Bye-bye.